So in this video, we're going to be writing the code for the lights, and this is going to be borrowing heavily from the code we used to write the pump because it's very similar, but we're going to be introducing a new concept here known as multiprocessing or concurrent programming. And what this allows us to do is to have two things running simultaneously. So usually when you write a program, you know how it works. It just goes line by line. So it executes the first line, second line, third line. That's the gist of it. When you're doing multiprocessing or concurrent programming or whatever you want to call it, you can do multiple things in parallel. So you can do two different functions running at the same time. So instead of doing only one thing and then doing the next thing and then doing the next thing, you can be simultaneously doing two things at once. And this is really helpful for us because it allows us to run two different functions at once, i.e. the one that manages the manages the pumps and the one that manages the lights. And this will allow us to run those two functions at the same time. And that's good because we want them running at the same time. We don't want one running and then the next one running. We want them both running at the same time. So in this video, we're going to be writing the code for the lights, and then we're going to be going over introducing multiprocessing. And yeah, let's get started. Okay, so first thing I'm going to do is take some of this GPIO code that I wrote in pump.py and move that to the main.py file. And the reason I'm doing this is because I'm going to be reusing a lot of the GPIO functions like set mode and the pin numbers and importing it and everything. I'm going to be using that again in the lights.py file. So I thought it makes a lot more sense to have that in main.py file. We only have to write the code once. It's a lot easier. It makes more sense. So I'm also going to change the variable name to pump_pin. And that just allows us to use two different variables, one for the pump pin and one for the light pin, because obviously we need more than one pin. So let's create a new file, lights.py. And in main.py, we'll just rewrite some of this code, but for lights. So create a new variable called lights pin, and I'm calling this 17 because that's the pin I used. This might be different for you, and that's okay. Just make sure you're setting it to the number of the pin that you used in the relay when you set the lights. And then I'm going to copy this setup and output pin, or setup and output code, change the variable to lights pin. And what this will do is set up our lights pin as an output, and then set the output to low, which turns off the lights. So now we can copy and paste this pump.py stuff into lights.py since we're going to be reusing it a bunch, and rename the function. So obviously I still want this to be a while true loop because I want this code to be always running. But we're going to have to change it a little bit because I don't want the lights to turn on for 5 minutes and then sleep for 4 hours. That's not what I want, obviously. I want the lights on between 9 p.m. and 7 a.m. and then I want them off the rest of the day. So the way we're going to achieve that is I need to restructure this loop a little bit. And obviously I need to know what time it is. And the way we can get the time in Python is with this module called the datetime module. So we're going to need to import that up top, and from datetime import datetime because the datetime object is the one that you use to get the current time. So the way we get the current hour is datetime.now is the function, and then the attribute is .hour. And what this does is it gives us the current hour on a 24-hour clock. So this is really helpful because it will tell us what the time is. We're also going to need a variable called lights on, and this will save if the lights are on or off in this variable. And the reason we need to save this variable is we don't want to turn the lights on if they're already on, and we don't want the same thing with off. So we want to first check if hour is greater than 21, which in regular time means that if it's later than 9 p.m. or if hour is less than 7, which means that if it's so this if statement will be true if it's in between 9 p.m. and 7 a.m. We'll set the lights to on. Actually, we'll only do that if the lights are off, because if the lights are on, we don't want to turn them on again. So if the lights are off, we'll turn the lights on. And then we'll do another else here, which means that if we're not in that time period, if the lights are on, then we turn them off. And this could easily be written as an elif statement instead of a if-else statement, but I think it's a lot more clearer what I'm trying to do if you do it as an if else and then an if statement inside the else. So it's an important lesson is that don't always do the thing that's takes the shortest amount of lines, as the point of code is for it to make sense. So this makes more sense to someone reading it than if you did an elif statement, in my opinion. And then we'll do a time.sleep here. And what this will do is it will mean that the loop isn't constantly running. Because if we didn't have this here, that means the instant this loop finished, since it's a while true loop, it'll just start again. And it'll go over and over again. And the problem with this is that it'll burn out our CPU really quickly. And it'll take up a lot of power. So putting this time.sleep in here just means that we're only going to run the loop every 5 seconds. This makes it a lot easier on our CPU, and it's just a lot more efficient. So I think this is good, but I have to set the lights on variable. So when we turn the lights on, I have to set the variable to true, and when we turn the lights off, we have to set the variable to off. And that should be good. So now this function that manages our lights is working. And that's all the code we need. So now what we can do is we can go back over to the main.py file, and then we can import this function in there and try and get it to work alongside our manage pump function that we have on our other in our other file. So we'll just do the same thing. From lights import manage lights. Here we go. And then this is where we run into our problem, right? Because if you remember what we talked about in the intro, is that when you run a program, it runs line by line. So the first thing it will do is call this manage pump function, which as you can see is just a while true loop, which runs forever. So we run into the issue of you can't get to the next line. So once you get to that line 16, the manage pump line, you'll never go to the next line because you're stuck in a while true loop. Which obviously is bad because we want to manage the lights and the pump, not just the pump, which is not great. So what we need to do to solve this problem is we need to do some sort of concurrent programming or parallel processing. And the way you do this in Python is there's different ways, but the way that we're going to use here, because I think it's the simplest, is this module called multiprocessing. And what this allows you to do is create different processes. And what a process is it's just a separate piece of code running that runs independently. So when you start a process, your main program, your main.py, can move on to the next line in your program while that process still runs. And that's going to be really helpful here because we can create different processes for each of our functions, and then we can run them in the background while moving on to the next line, which means it's not the while true loop isn't going to block up our whole function. So what I'm doing here is I'm creating multiprocess.process. This is how you create a process. And then we need to specify a target, which is the function we want, and then we're going to set it as daemon. And what it means for it to be a daemon is if it's a daemon, when the main.py file ends, the subprocess that we're creating will also close automatically. If it wasn't a daemon, the process would run even when the main file terminates, which we don't want. So let's set that up. And then to run these processes, we need to do the process.start, and that's a function call. And the problem with this here that we have now is that once we start these two processes, since it just moves on to the next line, it'll just start the pumps process and then move on to the next line, which is the end of the main.py file. And then since we set them as daemons, then they'll both just finish immediately, which obviously is bad because we don't want them to just stop. So we need to have some sort of a loop that keeps our main.py file running so that these processes don't immediately terminate when main.py terminates. And the way we're going to be doing that is with a keyboard interrupt, which you can do on your keyboard, which I'm pretty sure is Option C or Control C on Mac. And we're going to be just constantly doing this while true loop, which keeps us locked in main.py file so it never terminates. And then we'll do a try and accept case, which I think you guys know about. And what this will do is if we ever do a keyboard interrupt or Option C on your keyboard, it will run this code that I'm writing. So we're going to first call gpio.cleanup, which just does a bunch of stuff when you're closing a GPIO program. It resets all the GPIO pins. It's good practice to do. We'll write some nice output. Let's say we're exiting, and then we will exit with exit status code 0. And then since that's exiting main.py, then our two sub-processes, lights process and pump process, since we set them as daemons, will also terminate as well. So what this allows us to do is some really clean way to not have random processes running in our computer, so that whenever we do a keyboard interrupt, it will immediately then close the program and then close the two processes. So this multiprocessing allows us to run lights.process, or allows us to run manage lights and manage pump, which if you remember are two functions with while true loops in them at the same time. And this is critical because we obviously need to be doing these two things at the same time, since we can't just manage the pumps or the lights. We need to do them together. So this is why multiprocessing is critical here. This is just an intro to multiprocessing. There's many other ways you could do this, and if you're curious or confused, definitely look them up. There's lots of resources online. But this is just the basics for what we need here.